with climate change, and because there is an increase in global mean surface temperatures, we see that there is also an increase in the temperature trends in any global regions. And as a consequence, there will be more instances of heat extremes in any given part of the world. Before we started putting carbon dioxide emissions into the atmosphere, the world was 1.2 degrees Celsius cooler. And using this threshold, we can see what the chances of the same event would have been in a world without climate change. Trying to find an answer to such questions is important because people are interested in understanding what the role of climate change is in such events. And we need to know these answers to be able to make policies going forward to adapt and mitigate to such changes in the future as well.
Climate, der Podcast zu Klimawandelfolgen und Anpassungsstrategien.
Hallo und herzlich willkommen bei Climate. Mein Name ist Nina Hensch, ich bin freie Journalistin. Einmal im Monat widme ich mich gemeinsam mit ExpertInnen dem Thema Klimawandel, seinen Folgen und wie wir uns bestmöglich darauf vorbereiten können. Schön, dass ihr dabei seid.
Climate, der Klimapodcast mit Nina Hensch.
It was a summer of weather extremes. Heatwave in Spain, floods in Libya, forest fires in Greece, tornado in Italy, plus the hottest July since records began. That's what I'm talking about today with Mariam Zachariah. She is working as a researcher at Grantham Institute for Climate Change and the Environment at Imperial College London. Mariam, great to have you with us. Could you briefly introduce yourself? What do you work for? What are your topics?
Thank you, Nina. Thank you for having me on your show. I am Mariam Zachariah, and I work for a project called the World Weather Attribution. And I work with Dr. Friederike Otto at the Grantham Institute in Imperial College London. So at World Weather Attribution, what we do is we try and understand whether and to what extent climate change has played a role in making the events, the recent extreme events like droughts and floods that have a lot of human impacts, and what exactly is the role or how much has such events been due to climate change. And trying to find an answer to such questions is important because people are interested in understanding what the role of climate change is in such events. And we need to know these answers to be able to make policies going forward to adapt and mitigate to such changes in the future as well.
Mm-hmm. So you are working on assigning extreme events as close in time as possible and trying to find out whether climate change has something to do with it?
Exactly. And we are able to do that because we have the methodology in place. So talking about extreme event attribution, this is relatively new, having the first study having come out back in 2010. But since then, there has been a lot of development, and now we know enough, and now we know how to do or how to work with this science so as to provide insights meaningfully. And at World Weather Attribution, we are able to do this because we have the methodologies peer reviewed. So we have a strict protocol that we follow right from triggering the event. And before that, I also have to say that we are able to do this because we have a big group of people working on at any given time. Broadly speaking, we have a team from the Red Crescent Center who closely monitors extreme events as and when they happen. They monitor the impacts and then they trigger the events based on, what fraction of the community was affected or how much is the loss. And then what we do is we reach out to people in that region, people, scientists in that region who are willing to contribute. And then we use both observations and climate models to understand what this role of climate change is in that event. And then we also support these findings, what were the vulnerability and exposure components in addition to this climate change that made the impacts particularly severe, and what is it that needs to be done in terms of combating such events going forward.
Wow, this is much. We're talking about it a little later. Cards on the table. How climate neutral were you today?
Well, it's very hard to, quantify, because some of the things that we do quite unconsciously. Like, for example, right now I'm chatting with you and I'm sitting in a well-lit room, and unconsciously I'm avoiding the need for any other electricity apart from the powering source that needs to charge my laptop at the moment. That is the first thing that comes to mind. Today, my son walked to school. I walked our son to school. So that is another thing. So I avoided the use of needing a vehicle today. I did a little bit of shopping in the morning, and I needed some vegetables. I carried my own bag and I bought them loose. So I try to avoid packaging as much as possible. I walked back. I had a quick coffee, but then I ate some cereal with, milk from the shelf. So, yes, so there are things that I did. And I had a bucket bath, if I can add. So I had also limited water in the shower. So there are things that gets worked into my daily routine, I should say.
You are engaged in attribution research at World Weather Attribution, you said. In the case of an event, it can be used to deliver results as quickly as possible. How close can we go back with it this year? 2 months, maybe one?
The fastest we have been able to do bring out a study with its results was in a frame of a week. And I should say this is also dependent on the event that we are looking at. For example, if it is heat waves, it is very straightforward as compared to, let's say, a flood, which also has a lot of nuances associated with it because of the dynamics that come into play. And then it also depends on, how well or what region is it that we are looking at, whether we have good observations over that region. So if everything works out, we can very quickly deliver these results, because we can work on very short time scales. And the quickest we have got out a study was in a frame of a week this time. And that was with the study on the heat waves that happened early in July in the Northern Hemisphere and most parts of the Northern Hemisphere.
Wow, this is enormous. We are switching to Switzerland somewhat. There, for example, there was a temperature difference of 30 degrees within 4 days at the end of August. First, there was a bikini, then hats and gloves season again. How can this be explained?
This chaotic and unpredictable behavior of weather, which causes, rapid changes or shifts between, hot or cold and drought and heat waves. This is what is known as a weather or climate whiplash. Now, the very quick drop from heat waves that was accelerating glacier melt in Switzerland, and then this sudden shift to freezing temperatures. We know that it was caused by a major storm system moving into the region that had till then been under the influence of an anticyclone. But a local meteorologist would be better placed for an expert assessment on how these conditions evolved during that time, and that led to this abrupt swing in temperature. But what we can say is that because extreme weather events are becoming more frequent, the chances that we will see such extreme weather events in quick succession is increasing. So we can expect to see such events in Switzerland and in other countries. There will be more frequent instances of climate whiplash due to climate change.
According to the Copernicus Climate Change Service, July 2023 was the hottest month since weather records began. On land and in the oceans, the program registered record values. We remember well the extreme heat this summer. Southern Europe and many other parts of the world were affected. According to your research, that of the WWA, this heat is clearly due to climate change. How did you determine that?
Well, as I was telling you earlier, we use both observations and climate models to make these conclusions. So what we do is we first use the observations to determine what are the trends in the variable that we are interested in. And in this case, it is the temperatures, of course. And with our understanding of the physics, we know that with climate change, and because there is an increase in global mean surface temperatures, we see that there is also an increase in the temperature trends in any global regions. And as a consequence, there will be more instances of heat extremes in any given part of the world. So we are quite confident in these findings. And then in terms of the numbers, what we do is we look at these trends in the observations, and then we are able to say, okay, in the observations length, what are the chances of seeing such an event in the current climate? And then using our methodologies, we extrapolate to climates of the past. And in this case, we know that before we started putting carbon dioxide emissions into the atmosphere, the world was 1.2 degrees Celsius cooler. And using this threshold, we can see what the chances of the same event would have been in a world without climate change. And from these numbers, we are able to determine how much of the event was due to climate change, or in other words, how much has climate change altered the likelihood of the event. And similarly, we can also determine, by how much degrees Celsius has the event been made hotter in the current climate as compared to the past. And using the same methodology, we are also able to extrapolate. And for that, we need climate models where we have projections for future scenarios, where we see, how we can expect these events, or by how much we can expect to see these events in the future in a 2 degrees Celsius warmer world.
So if emissions continue to rise and we exceed 1.5 degrees, what would that mean in terms of heat waves, for example?
The IPCC reports that have come out recently, in the report, there is a graphic that sort of brings out what we can expect in terms of heat waves if we exceed the 1.5 degrees Celsius and other warming levels, also 2 degrees to 4 degrees. So if the emissions continue to rise and we reach higher warming levels, we can expect to see more number of heat waves. On a global level, the IPCC report provides some numbers to help us understand in terms of numbers what we can expect. So, for instance, on a global level, on a global scale, an event that happens once in 10 years in the current climate will become 4 times more likely in a 1.5 degrees Celsius warmer world. And what that means is that an event that happens once in 10 years in the current climate, you can expect to see such an event at least 4 times. That is what it means. And similarly, for a more extreme event, let's say that is still extreme and it happens only once in 50 years in the current climate, you can expect to see such an event 8 times in 50 years in a 1.5 degrees Celsius warmer climate.
Bis hierhin hat's euch gut gefallen? Wenn ihr wollt, könnt ihr meinen Podcast und meine Arbeit auch finanziell unterstützen. Über PayPal oder die Plattform Steady. Geht dazu einfach auf mein Facebook-Profil Hensch Nina. Den Link findet ihr in der Info oder nutzt mein Insta-Profil Nina_Hensch. Hier steht der Link in der Bio. Dort findet ihr alle wichtigen Infos rund um dieses Projekt. Das Interview ist längst noch nicht vorbei. Jetzt geht's weiter. So that means they would be more frequent.
Exactly. Yes.
Wow. In Germany, we have to assume that there will be significantly longer dry phases in the summer. What could be strategies to prepare for this in the future, also in terms of water management?
Well, for any region, some of the immediate recommendations would be to increase forest areas and to increase green spaces so that we can also allow water retention when you receive precipitation. And then there is also the need to develop guidelines to build water distribution systems and to regulate how these systems should operate in case of shortages. And there is also the need for categorizing water consumers in rankings. I would just like to reflect on something that comes from my part of the world. I come from India. So we are a monsoon dependent country. So we have what is called a rainwater harvesting system, which is encouraged in every household so that, when it rains, you can sort of have your own source building up, which you can use during a drought phase. So measures like that will help. So depending on how the precipitation mechanisms work in different countries, you need strategies that cater to the countries in particular.
So that means water should not be piped out but collected to help overcome periods of drought.
Exactly. That would be one of the ways.
Okay. What is also of concern this summer is the increased warming of the Atlantic. Opinions for the cause drifted apart. Is it clearer by now?
To be honest, I'm not an expert, but reading reports and understanding from how the experts have explained this phenomena, we do know that there is an influence of both short-term atmospheric circulations in the atmosphere, and it is the North Atlantic Oscillation that determines the temperatures at the Atlantic Sea. Now, again, this is also compounded by the long-term changes that has been ongoing in the oceans due to climate change, because we know that oceans are one of the biggest absorbers of carbon dioxide. Now, as the temperatures increase and the waters warm, the ability to retain or to absorb carbon dioxide reduces. And consequently, what happens is that it also feeds into the warming that is happening currently, and it also affects the ecosystems, the ocean ecosystems.
The ocean has never warmed as much as it has this year since records began. Added to this is the unusually long duration. That was what you said, that the oceans absorb a lot of the heat generated around them, a depth of up to 2,000 meters, and in a few areas even deeper. It had become significantly warmer, right?
Yes, that is right.
What we often do not realize, sea temperature fluctuations are generally much smaller than on land. What does a warming like this year mean for many animal species?
Over land, a lot of the animal species have evolved to sort of thrive in a narrow temperature range. But this is not the case with oceans, where hot temperatures can disturb a wide range of ecosystems. One of the things that is often talked about is the coral reef bleaching. Now, this is because these cannot move, because these stay in one place. They cannot adapt to, or they cannot escape these warming temperatures. But in transition, this also means that the other species in the oceans would be migrating to different parts. And similarly, this is also true for the land. So basically, the migratory patterns, the predatory patterns of the animals are all dependent on the atmospheric circulations, on the weather patterns. So with climate change, as these patterns get disturbed or perturbed, it also affects the limit to which the animals can adapt.
So if they can't migrate, we will perhaps lose them.
Exactly.
At the beginning of September, a tropical cyclone with enormous water masses moved towards northern Libya. At the weather station Al Baida, 414 liters per square meter fell within one day. That is 3 times as much as during the flood in the Ahr Valley in Germany 2021. How could Libya be hit so hard by this cyclone?
The particular weather system from which the cyclone that hit Libya originated was the storm Daniel, which had earlier brought heavy amounts of rainfalls in Spain and Greece and Bulgaria. An important effect of climate change on extreme precipitation is that it makes extreme precipitation more intense. And the reason for this is that a warmer atmosphere can hold more moisture, and therefore when it rains, it pours. And this is something that we often see in places where we have good model simulations and observations. We see this increase in intensity associated with extreme precipitation. This also holds for Libya and the other affected regions during this year's Storm Daniel. We saw that there is an increase in intensity of up to 50% due to climate change in these parts.
Mm-hmm. And what do you think? Will this happen more often in the future?
As we continue burning fossil fuels, and if the warming continues unstopped, then what will happen is that we can expect to see such very intense extreme rainfall events also, yes.
So what actions can we take? For example, should cell broadcast be expanded? In some countries this already exists.
Going back to the example of Libya, one of the things that contributed to the impacts was the timing at which the event happened. So the extreme amount of rainfall that fell in that region caused 3 dams to break in that region. And it all happened very late in the night when a lot of people were still sleeping. So the warning was, there was not a lot of time to react. So in that regard, and also looking at examples from other parts of the world. So yes, of course, if we can act on the forecast and if we can warn people ahead, that if we can issue alerts, and more importantly, we have to understand how the reaction times work. So it is not just about issuing broadcasts, but we have to develop a way to help people respond to the alerts also. So one of the ways would be to improve impact-based, alerts. So that what that means is that instead of focusing on meteorological, like the amount of rainfall, so there needs to be alerts in place. Like for example, for heat waves, we have the red alerts, orange alerts, and green alerts, depending on the temperature thresholds and what it means for human health, and associated impacts. So there needs to be impact-based forecasts for extreme rainfall as well. Improving such forecasts can help address this to some extent in the immediate context.
And how could we prepare ourselves also in relation to our infrastructure?
There is a lot of migration happening in the context of climate change. So regions that are almost always affected by such catastrophes, we have large-scale migration happening. So there needs to be ways to help build a resilient infrastructure. An important aspect of climate change is that because, there are trends in, let's say rainfall or temperature. And these trends also affect the return periods or the design return levels that we use to develop infrastructure. And in that regard, it is important to review the design levels that we use currently in the case of existing infrastructure. And as we plan more infrastructure to be built, we need to factor in the climate change effect on these variables while determining the design levels.
Every few years, the weather phenomenon El Niño occurs and drives the average global temperature even faster. Does it also have something to do with climate change?
So El Niño and La Niña are 2 phases of a naturally occurring climate phenomenon called the El Niño Southern Oscillation. And as you said, this leads to a dramatic, year-to-year variation in the Earth's climate, with during an El Niño phase, the northern hemisphere becomes anomalously warmer. Similarly, it has the opposite effect on the southern hemisphere. Now, the relationship between climate change and stronger El Niño is a topic of ongoing research, and it is difficult to conclude, the exact implications of El Niño or the exact effect of global heating on stronger El Niño events. For instance, there was a recent study that concluded that the current sea surface temperature extremes that have driven by El Nino have intensified by around 10% as compared to the pre-1960 levels. Again, the study builds on previous studies which predicted that the frequency of extreme El Nino events could double over the next century due to faster surface warming of the Eastern Pacific Ocean. But with El Nino Southern Oscillation, the pattern, it takes up to a decade for the shift between the positive and the negative phases, which is the El Nino and the La Nina. And therefore, it is difficult for scientists to confidently connect the intensity of ENSO phases with climate change. But then the IPCC report predicts that the frequency of strong El Nino and La Nina events is likely to increase throughout the next century.
So it can exacerbate the consequences of climate change?
Yes, it can. Yes. So, for example, this year we have an El Nino, and as a result, we have warmer than normal temperatures in the northern hemisphere, which has also been partly, exacerbating the temperature. So it's more like a preview of what we can expect under future climate warming, the conditions that we saw this year.
Mm-hmm. What impact will El Nino have on the hurricane season?
Again, I am not an expert on the links between ENSO and hurricanes, but as my understanding goes, El Nino favors stronger hurricane activity in the Pacific Basin, while it suppresses it in the Atlantic side. And conversely, during a La Nina year, it suppresses hurricane in the Pacific Basin, whereas it enhances it in the Atlantic side.
Mariam Zachariah, this topic will keep us occupied. Thank you for giving us an insight.
Thank you, Nina. Bye-bye.
Bye.
Climate, der Klimapodcast mit Nina Hensch.
Wenn euch diese Folge gefallen hat, abonniert gerne den Podcast oder vergebt das ein oder andere Sternchen. Ich freue mich über Feedback und Ideen. Schickt sie gern an Nina_Hensch auf Insta oder Hensch_Nina auf Facebook.
Climate, der Podcast zu Klimawandelfolgen und Anpassungsstrategien.